Problem number 16. A child of mass m holds onto the end of a massless rope of length L, which is attached to a pivot at height h above the ground. The child is released from rest when the rope is straight and horizontal. At some point, the child lets go of the rope, flies through the air, and lands on the ground a horizontal distance d from the pivot. On Earth, the maximum possible value of d is dE. If the setup is moved to the Moon, which has 1/6 the gravitational acceleration, what is the new maximum possible value of d? Problem number 17. Consider the following system of massless and frictionless pulleys, ropes, and springs. Initially, a block of mass m is attached to the end of a rope, and the system is in equilibrium. Next, the block is doubled in mass, and the system is allowed to come to equilibrium again. During the transition between these equilibria, how far does the end of the rope, where the block is suspended, move? Problem number 18. A satellite is initially in a circular orbit of radius r around a planet of mass m. It fires its rockets to instantaneously increase its speed by delta v, keeping the direction of its velocity the same, so that it enters an elliptical orbit whose maximum distance from the planet is 2r. What is the value of delta v? Hint: when the satellite is in an elliptical orbit with semi-major axis A, its total energy per unit mass is negative gm/2a. Problem number 19. A wheel of radius r has a thin rim and 4 spokes, each of which have uniform density. The entire rim has mass m, 3 of the spokes each have mass m, and the 4th spoke has mass 3m. The wheel is suspended on a horizontal frictionless axle passing through its center. If the wheel is slightly rotated from its equilibrium position, what is the angular frequency of small oscillations? Problem number 20. 4 massless rigid rods are connected into a quadrilateral by 4 hinges. The hinges have mass m, and allow the rods to freely rotate. A spring of spring constant K is connected across each of the diagonals, so that the springs are at their relaxed length when the rods form a square. Assume the springs do not interfere with each other. If the square is slightly compressed along one of its diagonals, its shape will oscillate over time. What is the period of these oscillations?